Resilience of agroecosystems, a brief explanation. Today we would like to talk about the resilience of agroecosystems. We call resilience the ability of a system to adapt to and recover from disruptions or shocks. Agroecosystems are very complex and dynamic systems. So how does such a system work? In agroecosystem created by mankind, self-regulating processes have less incidence than in natural ecosystems. They are very fragile and only stay stable by constant human intervention. Many processes run in these systems. They can be changed by altered anthropogenic intervention, but also by external factors such as extreme weather events. We want to illustrate that by using the model of a roly-poly. This is how a roly-poly works. The stable basis, we'll say the bottom part, is in comparison to the head heavy enough so that the figure comes to balance by itself after any turbulence or fluctuation. This ability of getting back to the original position helps us to understand the dynamics of agroecosystems. After small turbulences, the roly-poly comes back to balance by itself due to the stable basis. In case of too many or too heavy disruptive influences, the roly-poly will sway and possibly tip over. So what does that mean for our agroecosystem? A stable basis may be, for example, a farm management which uses ecologically sustainable farming systems, and the farmers include ecological, economic and social consequences in their decision-making process. They keep an eye on the interactions and dynamics triggered as a consequence of their management decisions. Let's get to the concrete example of cropland. The cropland should absorb and hold enough water, be well provided with nutrients, contain many soil organisms, and serve as a CO2 storage. Thus, the soil lasts against erosion. It continues to buffer damaging impacts and recovers back to its healthy structure. Non-sustainable management, however, destabilizes our agroecosystem. Monocultures in huge farmland units increase susceptibility for wind erosion and weather. Compaction due to the use of big machinery or excessive stock density results in surface runoff, erosion and silting. Over-fertilization and high pesticide use destroy a living soil. Along with climate change, more and more extreme weather events occur. Heavy rainfalls and storms, but also heat waves and droughts make the soil vulnerable. The ecosystem functions of the soil are being reduced. We call it degradation. So what kind of strategies for adaptation and sustainable management can farmers apply to make the cropland resilient so it can recover? Crop rotation, careful soil cultivation, catch crops, legume cultivation, and protective strips crossways to the slope. All these are adequate management measures for a stable agroecosystem cropland. As you have seen, an agroecosystem is quite complex. With a good and sustainable management, it can be maintained in its natural balance and able to endure some external stress. The closer an agroecosystem is to a natural ecosystem, the more stable it is.